In my last video, I experimented with increasing the thickness of a case's rim. On the left is a standard 4570, and on the right is one with a 25% thicker rim, better suited to be converted to an old black powder cartridge, such as 11mm Mauser. This was done by mounting the case in the lathe and using a forming tool with a ball bearing to fold the rim forwards. But one thing I discussed in the last video, but didn't do, was to make some sort of internal stop for the lathe. One that allows the cases to be positioned accurately, as well as supports them during the rim folding process. Back on the lathe, I have a Morse taper 3 center, centered in the lathe. This is the taper that's in the headstock, and I want to make the stop to fit within it. I have the center here so that I can set up the lathe to cut a matching taper. That is done by angling the compound slide to the same angle as on the taper. With an indicator set on the compound, I can drive it back and forth across the center. I'm looking for the needle to not move at all. If it does, I'll give it a few taps to adjust. It takes a lot of trial and error, but this looks okay. It's within a few thousandths, which is good enough for this purpose. Then I can get all of this removed in order to cut the taper on the end of this piece of stock in the chuck. Off camera, I added a few finishing touches, like filing the taper. The surface finish isn't great. Ideally, a taper like this should be hardened and ground, but this should work well enough as a stop. What I'll do next is to make a piece that has one end threaded to screw inside here. That will provide the length adjustment needed. Then the other end, I'll round off so it fits within the cases without damaging them. But before I move on to the lathe, I'll get the solid tool post back on. The compound slide on this lathe is very flexible, which is what creates the poor surface finish. The solid tool post riser I have is much more rigid, and I vastly prefer working with that. I also have the chuck removed so that I can first test the fit of the taper and the spindle. I'm not bluing the surface and checking for contact. I just want to see how well it holds in here. I'll give it a few taps to seat it fully. That's a solid fit. A few taps from the other end ejects it. It'll do what I want from it. Now to machine the adjustable stop. That's the two parts done. I'm adding a nut to the adjustable stop so I can lock it into position so it won't move as the lathe is running. I'll leave it long at first. Then get it into the spindle. And seat the taper with a few taps. Then I can add the case to see where it fits. That's actually a bit too long. It should be closer to the end of the collet so that it's supporting the thicker case walls near the base. Ideally, I'd be able to set the length with the stop remaining in the spindle. I could use a deep socket like this, one that will fit over the adjustment piece like so. But this is one size over the size of the nut, a 1/2 inch socket versus a 7/16 nut. Larger nuts for the size thread used exist. I'll have to track one down. But for now, to adjust the length, it needs to be removed. That's much better. The case is now well supported with it sitting deeper within the collet. I'll get the lathe set up to fold over the rim. I do still need to use the indicator to see how far I'm folding the rims. I'll fold them over the same 30 thousandths that I was doing before. That result looks just like the cases did in the previous video. It did maybe feel a bit easier to do that, or maybe it's in my head. Either way, I feel better knowing that the case is well supported, and the stop is there to prevent it from moving backwards. An additional thing I want to test out is that instead of the rim being cut down to its final diameter, if it can be formed down instead. I'm switching around the bearing tool so that it can come in from the side. There's just enough clearance here, but first I'll measure the starting diameter. That's 611 thousandths. I'll feed the wheel straight in. The sides of the rim have flattened out. I'll check the diameter now. That's 600 thousandths on the dot, but my target is around 585. I'll keep going. I fed the cross slide in 10 thousandths, which should have taken 20 thousandths off of the diameter, but it's not a one-to-one translation like it would be when cutting. I'll keep going. It's 587 thousandths now. That's good enough. It doesn't appear as if the material flowed forward at all. The rim thickness seems about the same as it did before. Instead, it all looks to have flowed back, adding a sharp corner where the chamfer was from the rim being pushed forward. I'll measure just in case the thickness increased. No, it doesn't look like it did at all. It's still a similar 85 thousandths as all the other cases were. As far as I'm concerned, cutting the rim down to its final diameter or forming it down are interchangeable. That's because, as said previously, this bottom corner isn't important. And even in some cases it may be a hindrance, such as on the A base on an 11mm Mauser cartridge. Here is the bolt from my Mauser 7184. Looking closely at the bolt face, you can see why the base of the cartridge is stepped like it is. This surface here, the face of the ejector, doesn't fit flush with the rest of the bolt face. Instead, it's proud, intended to help kick the cartridges out after being fired. Using the end of the calipers to measure, I'll first get the depth of the bolt face. Then from the end of the bolt to the surface of the ejector. The result is that the ejector is proud from the bolt face by 26 thousandths. The practical result of this is that if a case has a flat base, like this one formed earlier, it won't sit flat. You can see the angle it's at as I force it against the bolt face. In comparison, the dummy round with the A base will sit flat and in line with the bolt. Then as the bolt is pulled back, the ejector will tip out the spent case. I want to be able to cut the A base of the 11mm Mauser in a way that's simple and repeatable. To do so, I'll grind this piece of high-speed steel to shape in order to act as a cutter. Using a bench grinder to simply round off one corner should do the job. This cutter should work well. The rounded corner matches the A base of the 11mm Mauser dummy round well. I'll use it to cut a matching relief, feeding it across, like so. I'll get the case tightened in the collet chuck. Then switch to form tool for the cutter mounted in a tool holder. I will need to adjust the height so that the cutting edge is on the center line of the case. It takes some trial and error, but I'm just eyeballing it. It doesn't need to be perfectly aligned. Brass is pretty forgiving. This time, I'll eyeball how deep the cutter should be, using the base of the dummy round to compare. Right about there should work. Then I'll touch off the rear of the case and add the indicator so that I can control how deep to make the A base. I'll set it to 30 thousandths. Then I'll feed it in until the needle reaches 0. That looks good to me. Maybe the cutter was a bit too far in left to right, but this should work well. Yes, the central part of the base does look to be a bit smaller than the dummy round on the right. There really isn't a good way to measure just how far it's off, but this should give some sort of an indication. But what's really important is if the case sits flush on the bolt face. Because the base is smaller, it's tougher to align it straight, but it doesn't look like the corner of the rim is touching the ejector face, at least until it would kick out the case. Again, just like last time, this is a conceptual video, not a how-to, but a test to prove that thickening a rim on a case is possible, and if that rim could then be formed or cut to shape. But I don't think the middle step of forming the diameter down to size is worth the effort, so this is the progression lineup I would follow. Left, folding the rim to increase thickness. Middle, cutting the rim to diameter. Right, cutting the A base. Perhaps a more advanced cutter can be made to do both middle and right at the same time. But regarding the whole process, let me know your thoughts down in the comments. And as always, thanks for watching.